Hello everyone. Scuba diving is a mode of underwater diving whereby divers use breathing equipment that is completely independent of a surface air supply. The name scuba, an acronym for self-contained underwater breathing apparatus, was coined by Christian J. Lambertson in a patent submitted in 1952. Scuba divers carry their own source of breathing gas, usually compressed air, affording them greater independence and movement than surface-supplied divers, and more time underwater than free divers. Although the use of compressed air is common, a gas blend with a higher oxygen content, known as enriched air or nitrox, has become popular due to reduced nitrogen intake during long and/or repetitive dives. Also, breathing gas diluted with helium may be used to reduce the likelihood and effects of nitrogen narcosis during deeper dives. Open-circuit scuba systems discharge the breathing gas into the environment as it is exhaled, and consist of one or more diving cylinders containing breathing gas at high pressure, which is supplied to the diver through a diving regulator. They may include additional cylinders for range extension, decompression, gas, or emergency breathing gas. The volume of gas used is reduced compared to the open circuit, so a smaller cylinder or cylinders may be used for an equivalent dive duration. Rebreathers extend the time spent underwater compared to open circuits for the same gas consumption. They produce fewer bubbles and less noise than open-circuit scuba, which makes them attractive to covert military divers to avoid detection, scientific divers to avoid disturbing marine animals, and media divers to avoid bubble interference. Scuba diving may be done recreationally or professionally in a number of applications, including scientific, military, and public safety roles, but most commercial diving uses surface-supplied diving equipment when this is practicable. Scuba divers engaged in armed forces covert operations may be referred to as frogmen, combat divers, or attack swimmers. A scuba diver primarily moves underwater by using fins attached to the feet, but external propulsion can be provided by a diver propulsion vehicle, or a sled pulled from the surface. Other equipment needed for scuba diving includes a mask to improve underwater vision, exposure protection by means of a diving suit, ballast weights to overcome excess buoyancy, equipment to control buoyancy, and equipment related to the specific circumstances and purpose of the dive, which may include a snorkel when swimming on the surface, a cutting tool to manage entanglement, lights, a dive computer to monitor decompression status, and signaling. Scuba divers are trained in the procedures and skills appropriate to their level of certification by diving instructors affiliated with the organizations which issue these certifications. These include standard operating procedures for using the equipment and dealing with the general hazards of the underwater environment, and emergency procedures for self-help and assistance of a similarly equipped diver experiencing problems. A minimum level of fitness and health is required by most training organizations, but a higher level of fitness may be appropriate for some applications. The history of scuba diving is closely linked with the history of scuba equipment. By the turn of the 20th century, two basic architectures for underwater breathing apparatus had been pioneered. Open-circuit surface-supplied equipment where the diver's exhaled gas is vented directly into the water, and closed-circuit breathing apparatus where the diver's carbon dioxide is filtered from exhaled unused oxygen, which is then recirculated, and oxygen added to make up the volume when necessary. Closed-circuit equipment was more easily adapted to scuba in the absence of reliable, portable, and economical high-pressure gas storage vessels. By the mid-20th century, high-pressure gas cylinders were available and two systems for scuba had emerged. Open-circuit scuba where the diver's exhaled breath is vented directly into the water, and closed-circuit scuba where the carbon dioxide is removed from the diver's exhaled breath, which has oxygen added and is recirculated. Oxygen rebreathers are severely depth-limited due to oxygen toxicity risk, which increases with depth, and the available systems for mixed gas rebreathers were fairly bulky and designed for use with diving helmets. The first commercially practical scuba rebreather was designed and built by the diving engineer Henry Fluess in 1878 while working for Seb Gorman in London. His self-contained breathing apparatus consisted of a rubber mask connected to a breathing bag, with an estimated 50 to 60% oxygen supplied from a copper tank and carbon dioxide scrubbed by passing it through a bundle of rope yarn soaked in a solution of caustic potash. The system giving a dive duration of up to about 3 hours, this apparatus had no way of measuring the gas composition during use. During the 1930s and all through World War II, the British, Italians, and Germans developed and extensively used oxygen rebreathers to equip the first frogmen. The British adapted the Davis submerged escape apparatus and the Germans adapted the Draeger submarine escape rebreathers for their frogmen during the war. In the U.S., Major Christian J. Lambertson invented an underwater free-swimming oxygen rebreather in 1939, which was accepted by the Office of Strategic Services. In 1952 he patented a modification of his apparatus, this time named Scuba, an acronym for self-contained underwater breathing apparatus, which became the generic English word for autonomous breathing equipment for diving, and later for the activity using the equipment. After World War II, military frogmen continue to use rebreathers since they do not make bubbles which would give away the presence of the divers. The high percentage of oxygen used by these early rebreather systems limited the depth at which they could be used due to the risk of convulsions caused by acute oxygen toxicity. Although a working demand regulator system had been invented in 1864 by Auguste de Nauruze and Benoit Roquirol. The first open-circuit scuba system developed in 1925 by Yves Le Prieur in France was a manually adjusted free-flow system with a low endurance, which limited its practical usefulness. In 1942, during the German occupation of France, Jacques-Yves Cousteau and Émile Gagnon designed the first successful and safe open-circuit scuba, known as the Aqualung. Their system combined an improved demand regulator with high-pressure air tanks. This was patented in 1945. To sell his regulator in English-speaking countries, Cousteau registered the Aqualung trademark, which was first licensed to the U.S. Divers Company, and in 1948 to Sieb Gorman of England. Sieb Gorman was allowed to sell in Commonwealth countries but had difficulty in meeting the demand, and the U.S. patent prevented others from making the product. The patent was circumvented by Ted Eldred of Melbourne, Australia, who developed the single-hose open-circuit scuba system. Taking your leave, thank you all very much. Please like, share, and subscribe.